This is a demonstration for Lab 5, PTRT 1473. I'm going to be demonstrating what you need to do for Lab 5. Now, Lab 5 deals with the well performance. We're going to be constructing the inflow performance and tubing performance for oil and for gas. Actually, we only do TPR for gas, but we're going to be doing the IPR for both oil and gas. So I gave you the data. I'm going to use a similar data. When you are constructing yours, you have to use your data. So I'm going to use a similar data. Let's do the oil first. So this is the data I'm going to use to demonstrate. Reservoir pressure 5,000. Bubble point pressure 3,000. Tested bottom hole pressure is 4,000. Tested flow rate is 300. So we go to, we are going to be calculating the these parameters, the productivity index, that's also called J. That's what you have, J. Then we'll find the Q max and the flow rate at the bubble point. So let me go here. I'm going to copy. These are the three equations we need for those. Those are the three equations we need for this exercise. So the first thing to calculate is the productivity index. We have to calculate the productivity index from here. That's the simplest equation there. And this is for the maximum. We will need this to find the productivity index and also to find the QB. So let's find the productivity index first. Equals. Okay, let's look at the equation. Flow rate equals productivity index multiplied by difference between the reservoir pressure and bottom hole pressure. We will only need the tested point to find the productivity index. And that's the only time we're going to be using this tested point. We just need it to find the productivity index. So let's look at the equation. If you rearrange this equation, the productivity index J equals the flow rate divided by the difference between the reservoir. So the flow rate, I have to click the flow rate. The tested flow rate is 300 divided by, I open the bracket, reservoir pressure 5,000 minus the tested bottom hole pressure, which is 4,000. I close the bracket. So that's my productivity index, 0.3. No, in your own case, it's going to be different. So don't just copy my data. I give you here, I think 3360. I give you 4,500 here. So it's going to be different. Then, the next thing is to find Q max. I will find Q max from this equation here. So let's type Q max. Q max equals J, which is productivity, I'll click on that, multiplied by, I open the bracket, reservoir pressure, I click on that, minus bubble point pressure, I click on that, plus bubble point pressure divided by 1.8. So I click on this again, slash 1.8. Then I close the bracket. That's Q max, 1100. QB. Now for QB, which is the flow rate, the bubble point pressure is our boundary. So anything above the bubble point, this is the valid equation. Anything below the bubble point, this is the valid equation. But at the bubble point, any of them, both of them are valid. So in order to find the flow rate at bubble point, the easiest, we're going to use the simplest equation. If I use this two, I'm going to get it. No, I can't use this because I have QB here. So I have to use this. This is the simpler equation. So I'm going to do equals J, which is this. I click on that. Multiply by I open the bracket, reservoir pressure, which is this, minus. Now, the bottom hole pressure now is the reservoir, when the bottom hole pressure is bubble point. So I'll click on the bubble point. So minus bubble point. So that will give me the flow rate at bubble point. So now I want to construct the IPR. So the IPR, the bottom hole pressure will vary from 0 to the reservoir pressure, which is 5,000. Because the bottom hole pressure cannot be greater than 5,000. So I'm going to 0. The next one, I want to do interval of 500. The next one will be 500. So I'm going to, let me first of all create the table here. I'm going to highlight these two. I do this. I'll grab that until I get to 5,000. 5,000. Okay. Now, if I actually have 5,000 and maybe 5,050, so I have to do up to 5,000, then I'll type 5,050 there. In your own case, you are doing, okay, I don't think you have that problem. Okay, so now, remember, see what I do here? I put my flow rate on the left and bottom hole pressure on the right. Always use that convention because it's easier. When you go to construct the graph, it's going to be easier for you. You see what I mean? So I'm going to do, I'm going to calculate from 0 to 5,000. But I know that the equation, I have two equations. This for below bubble point and this for above bubble point. So I have to know when to change. I have to find what's my bubble point pressure. Bubble point pressure is 3,000. So let me see if I have 3,000 here. So the equation is going to change there from there. So below I will use this equation. Above I will use this equation. So let's use the first equation. Now before I use the equation, you see all these parameters I calculate here. I told you the only numbers I'm only going to use once are the tested point, which I use to find the productivity index. These other ones, all these other numbers, I'm going to be needing them in the calculation. So the best way to do is to name them so that when I copy, it won't change reference. So for example, this is reservoir pressure there. I'll go here, you highlight the C2 there. I'm going to give it a name, just give it any name. Reservoir. Let me see, then you do enter. So the name is entered. Now this is bubble point. So let me name this bubble point pressure. I don't need to name the tester point. So this is productivity index. I like this. I name it, let me see. Productivity index. Just use whatever you want to name. Okay. I do enter. Then this one, Q naught max. So I'm going to call this Q naught maximum. Then this is flow rate at, I highlight that. I say bubble flow rate at bubble point, bubble Q. Okay. Okay, so this, what I'm going to do now, you see that anytime I enter the formula, it's going to just put the name. It's not going to put the reference. Now let's find for bottom hole pressure of 0. We start from there. You see that when the bottom hole pressure is 0, that should give you the maximum. That should give you 1100. Okay, so I'm going to do equals. We are using this equation now. So equals, I open the bracket, Q naught max, I click on it, minus QB flow rate, this is QB there, I click on that and I close the bracket. Then multiply by, I open another bracket, 1 minus 0.2, 0.2 multiply by star, we put that in bracket, multiply by, I open another bracket there, multiply by bottom hole pressure. My bottom hole pressure now is, this thing is covering it. It's D12. So I'll put D12 there. D12 slash bubble point pressure. I'll click on bubble point pressure, which is here. I close the bracket. Then minus 0.8 multiply by, I open another bracket. My bottom hole pressure again is D12 because this equation is covering it. So I'll type D12 there, D12 divided by bubble point pressure. I click on it. I close the bracket. Now, squared, which means to the power of 2. So I'm going to do shift 6. Shift 6 will give you the power. The power 2. That's cap 2. Then I close the bracket again, the final bracket. If I enter, it should give me 1100. No, it should give me 1100. That's the maximum. Oh, I didn't do plus. You see, the last one is plus QB. Plus QB. I have to click on QB again. 1100. Okay. So what I'm going to do is, this equation is going to be valid up to 3000. So I'm going to copy it. I grab it up to 3000. You see? At 3000, it gives you 600, which is the same thing here. And at 0, it gives you 1100, which is that. So it should give you between this and that. Okay. In your own case, I think the bubble point pressure might not fall in here. But you have to do anything below. This should be below the bubble point, and then the next one should be above the bubble point. So, okay. So, now above the bubble point, I'm going to use this equation. So, I'm going to change the equation now. Equals flow in the productivity index, which is J, multiplied by, I open the bracket, reservoir pressure, minus, see the equation is covering the cell. This cell again is what? What is this cell? That's D12. D19. It doesn't mean it has to be D19 in your own case. You just, so that's D19, that's the cell here under the pressure column. Okay, so that's 450. Okay, you see, the last number must be 0 if it doesn't give you 0, because when the bottom hole pressure is equal to the reservoir pressure, there's no inflow. So that's what you have there. So I'm now going to construct the IPR. I'm going to do, I light from the title Q up to the last number there. Then I go insert. I open you open this scatter. You pick on this. No, just on the curve one, the smooth lines. No data point, okay? That's what I need you to do. Now, what you need to do now is, this title is actually, just change that to oil IPR. Oh, first of all, before you do that, I need to add, or you can do this, quick layout. Pick the first one so that I can add the title there. I click on the title, I write bottom of pressure. Put PSI in bracket, PSI. Then this axis is the flow rate, inflow rate. You can write inflow rate or flow rate, it doesn't matter. Flow rate, and this is in what? Stock tank barrel per day. Okay. So you see, I don't need this legend because I'm only constructing the upper, so I delete the legend. One thing you need to do when you are constructing, let me see, okay, I don't need to go up to 6,000, so I'm going to do this. This one too goes to 1100. Okay, let me leave that. Change this to oil IPR. What else do I need to do? So I need to add, let me add all the grid lines. It's always good to add all the grid lines. Grid lines. Just click on all of them. Okay. That's it for oil. Now the next one is to do for gas. I'm going to click on, so you name this sheet oil. I should delete this. Delete this. So I'm going to name this sheet oil. Then the next sheet I'm going to do for gas. Okay, I have to delete all this again. No, which one? Is that the one I gave? This is the one you're going to be doing. I have to change my number. Let me do, for gas, I'm going to do a different one. I'm going to do a different one. Let me see. I think this is the same number I gave to you. I'm not going to construct that. I'm going to do a different one. Okay, so let me do a different one. Let me do the one you have in your... I'm going to use this, the example, the one you have in the example here. Okay, I'm going to use this. We're going to be using the raw lanes for gas. So we're going to be, for the IPR. Let me see, I'm going to do this data. 4505, that's the reservoir pressure. Then 0.658. So reservoir pressure is 4505. And is 0.658. Let me delete this. The tested point. Tested point. Let me use 1152 3025. 11 flow rate. 1152 for flow rate. Flow rate is 1152. 1152 3025. Tested 3025. Okay. So here for, and you are given the N as that. For gas, the only thing I need to calculate is the Q max. Now let's look at the equation now for gas. Let me go. These are the two equations you need for gas. These are the two equations I need for gas. So I would need this for the Q max. Now, so let's calculate Q max. You say equals Q, the tested flow rate, which is that divided by, I start with a bracket, 1 minus bottom hole, tested bottom hole pressure, which is this. No, I have to start with a bracket. Sorry. I open a bracket. Then tested bottom hole pressure slash reservoir pressure. Then I close the bracket to power of 2, which is cap 2. Then I close the bracket. Then I do another power to power cap N. So I click on N. So that should give me my maximum flow rate. 1709. Okay, you see that in the, I gave you that in the on canvas. So 1709, that's the maximum flow rate. So I'm going to do my IPR. The pressure will be, this is the pressure. Pressure will vary from 0 to 4505. So I'm going to, let me use again interval of 500. I highlight the 2. $45. Oh, sorry. So 45, the last one should be 4505. So I'll just type that 4505. Okay. So I'm going to do, I have to, for gas, it's not like oil. For gas, it's only one equation. It's only oil you change at the bubble point. There's no bubble point there. So I have to, this is the only equation I need to use for flow rate. So I have to enter that equation, which is, I say equals Q max. I click on Q max, multiply by, I open the bracket, 1 minus. Now my bottom hole pressure will be this point there, which is, in this case is what? D10. D10. Now I have to put it in, I have to open the bracket, sorry. Minus, I open a bracket, then D10 divided by reservoir pressure. I click on that again. Oh, wait a minute. I did. Oh, okay, I named it. See, I named it PR gas. Don't forget to name it. If you don't name it, then you have to know how to use the $sign to fix cells. Okay, then I close the bracket. I do cap shift 6, then cap what? 2 squared. Then I close the bracket. Then I do shift again, cap. Then I click on N. That's N. Then I enter. You see, the first one should give you the maximum. Then the last one should be 0. So let's do this. If I, oh, Jesus. If I double click on this, it will do everything. Okay. I double click on the cross. Okay, so it has calculated for, so I'm just going to highlight everything. I do insert. I open this. I do that. Okay. Now for this, for the for gas, I have to widen this. I have to make it big because I'm going to need to read the, okay, so that's the IPR. Now I give you the data for TPR. Now it's going to be different for this one. So where's the data? I need to go get the data for. Now the data for TPR. I need to go to the next page. This is the data for TPR. Okay, this is my data for TPR. So I'm gonna. Okay, so. Okay, now, this is my IPR. Now I need to. Again, I'm going to use. I'm going to put axis title. Okay. Then grid lines, I'm going to use all the grid lines. What else do I need? Now the legend, I put the legend at the bottom. Okay. Okay, so now what we need to do now is to add the TPR data. So what I'm going to do is you right click on anywhere on the graph, you do select data. So this is the one we have. Now I want to add. You click add. The title is TPR, so I'll click on where I have TPR, which is that. X value. The X value is always the flow rate. So I'll click from here to here. So that's it. Now the Y, I have to clean